Good afternoon. I'm Aditya Kumar, and today I'll be talking about test-driven development, which is an agile approach to building reliable software. Without further ado, let's proceed. Now, what is test-driven development? Test-driven development is a software development technique where tests for this. Yeah. So, test-driven development is a software development technique which tests are written before writing the actual code. This counterintuitive approach was introduced by Ken Peck as a cornerstone of extreme programming, which is one of the most rigorous agile technology methodologies. At its heart, test-driven development focuses on writing small, testable pieces of code iteratively. Rather than building an entire feature and then testing it, developers create bit-sized units of functionality, each backed by a corresponding test. This approach ensures that every line of code serves a validated purpose. So the key principle, test-driven development emphasizes testing early and continuously, catching bugs before they become costly problems deep in your code base. Test first, then code. The core philosophy of test-driven development is elegantly simple, yet profoundly powerful. By reversing the traditional development order, writing tests after. Apologies. So, where was I? Okay. So, writing tests after implementation, developers establish a clear contract of what the code should do before they write a single line on it. This ensures software correctness and reliability at every step of development. When you write the test first, you're forced to think critically about the problem domain, edge cases, and expected behavior. The code becomes a solution to a precisely defined problem, not a solution in search of a problem. Proceeding. The test TDD cycle. Now, test-driven development operates in a precise three-step cycle that repeats for every new feature or improvement. Now, read here, write the test case for a feature that doesn't exist yet. Route it failed intentionally. This establishes the basics. So basically, whenever you're introducing a new feature, before you exit and start building the code, you develop test cases which define what the function or what the feature is supposed to do. Now, obviously, when you're trying to execute it the first time, it will obviously fail because generally we haven't started building the software yet. Now, green, write the minimal code necessary to make test pass. So basically, we're making a prototype which satisfies test cases we built in the first place. So the goal here is to pass the test, not to build the perfect solution. Turn to the third phase, refactor. Clean and optimize the code while keeping your test green. Improve readability, remove duplication, and enhance performance. So obviously, we made it prototype in the second phase. And in this phase, we are improving it. We are modifying it. We are smoothening it. We are refining it. And that's refactor. This cycle repeats continuously. Each iteration builds confidence and creates a growing safety net of automated tests protecting your code quality. Now let's see an example. Now suppose you have a calculator class that adds two numbers. So you have the first step is to basically write a test case. Test case we have dealt. This is basically the Java G unit actually. So we have defined a test case which is basically equating the expected value 4 to the sum, the output of the method. Uh, so yeah, the first is to write the test case. So uh, okay, so the step one is to write the test case. So here we are basically typing building. First we are writing the test case for the method. So asset equals 4 comma calculator will add 2 comma 2. Now this obviously when you run this, this show another this is show and obviously the test case will fail because obviously the add function doesn't exist, which is good. That's a baseline we are going to maintain. Now, second phase, the green phase, we implement the measurable code. So it define a function add and define, and we implement the functionalities of it. So basically, and add in a comma in b, return a comma a plus b. So obviously, when you run the test case now, the test now passes. Now notice we wrote only what was necessary, nothing more. This keeps the code base lean and more focused. Step three is the refactor phase. would involve reviewing the code for improvements. So in this case, it's already clean and maintainable. But suppose if you're dealing with huge lines of code or huge chunks of code where it contains multiple functions, constants, class mentions, objects, etc., refactoring will play a major role there. Now, what are the benefits of test-driven development? Well, includes clean code. Basically, your code becomes more organized and maintainable. Continuous testing. A frequent check feedbacks catches bugs when they're the cheapest fix. Well, if you're finding bugs during the development phase, cost to fix it is reduced. If it's after development deployment, it's gonna be expensive. Less debugging. Your test catches regressions immediately. You spend less time in debuggers hunting mysterious failures. Living documentation. Test cases give greater information about what a feature does than the comments. Yes, it does. Developer confidence. A comprehensive test suite is a safety net that lets you refactor boldly, knowing you will catch breaks instantly. Next, now we talked about test-driven development. We talked about its advantage. We talked about its benefits. We talked how it can be implemented. Now the question is, suppose you're thinking about implementing test-driven development in your project. What now? Obviously, now while this thing test-driven development is powerful, it is not a silver bullet. It is not that like easy to implement. Understanding its limitations will help you apply it wisely. So one of the main challenges is time investment. Now, obviously, initial development takes longer than you are while when you're writing test first, because obviously, first you're defining the test cases, then you're building on it. So obviously, it will take some time over there. But this cost is recoverable to reduce maintenance. So if you're building the test cases first and the modeling the features based on test cases, maintenance cost decreases because you don't need to work on the feature anymore because you already modeled the you're building the features based on the test cases. So you don't need to spend time maintaining it over and over again. So debugging time also reduces over the product lifetime. Testing discipline. Now what? Now this is one crucial thing because test-driven development requires strong team discipline. Developers must resist shortcuts and maintain testing rigor even under deadline pressures. Thirdly, your user interface and exploratory work. Test-driven development shines with business logic and algorithms, like we saw in the previous example, but struggles with obviously user interfaces. User interfaces are like not basically where TED can shine easily, and rapid prototyping where requirements are still being discovered. Now the fourth one, this is actually kind of important. Framework knowledge. Now we talked about testing development. We already took an example. So you obviously you will realize that you need to have a familiarity with testing frameworks. For Java, we have JUnit. For Python, we have PyTest. For JavaScript, we have Jest to be effective. This has a learning curve for newcomers. So when you're trying to implement JDTDD or you're using testing technologies or testing tools, you need to have a familiarity on how to use it. So long-term value, while TDD has an upfront cost, it pays dividends by dramatically reducing maintenance overhead and making future changes safer and faster. Now, obviously, TDD frameworks across languages. Across every languages, we have different testing tools formulated. For Java, we have JUnit, TestNG, Mockito. For Python, we have PyTest, Unit Test, Nose2. JavaScript, we have Jest, Mocha, Jasmine. C, we have NUnit, XUnit.net, PEX. Additionally, we have for Ruby developers use RSite, Go developers use testing. Rust has its own built-in test framework. As part of the let's see, test-driven development as part of the agile excellence. Now, test-driven development is far more than a coding technique. It is a cornerstone of the modern agile software engineering. Let's look into more detail. Extreme programming. Test-driven development is a core practice in extreme programming, enabling teams to deliver quality incrementally. Sprint-ready code. Test-driven sprints produce working, validated core software at the end of each iteration. CI/CD integration. TDD pairs perfectly with continuous integration pipelines that run tests automatically on every commit. Agile values. Test-driven development embodies agile Agile's commitment to working software, rapid feedback, and continuous adaptation. Let's come now. Conclusion. Test-driven development can be summarized as test first, code small, refactor often. This powerful combination ensures you build high-quality, maintainable software and that stands the test of time. Every test you write is an investment in future development, speed, and reliability. So, what can we gather for all this? First of all, ensure quality. Your comprehensive test suite guarantees that your code works as intended now and in the future. Second, embrace file early, fix early. Catch bugs during development when they're cheap to fix, not in production when they're expensive and embarrassing. And finally, deliver continuously. Test-driven development supports Agile's core component promise, delivering reliable working software that meets user needs with confidence. And with this, I conclude this session. Thank you for listening.